95% of pollution related to sulfur oxides are in the form of sulfur dioxide. Sulfur dioxide is the result of fossil fuels burning for electricity. In this diagram, we see the sulfur dioxide exiting the power plant and oxidizing in the air to form acid rain. When the acid rain falls on the plants, it causes damage to the entire plant. We also see sulfur oxides hitting the plants through the air, which is where we see more visible density. When sulfur dioxide gets into the atmosphere, it becomes widely distributed and diluted, which creates a huge effect on plants. Sulfur dioxide enters the plants through the stomata, which are pores where gas enters the plant. This can cause necrotic lesions or dead tissues. Here you can see the necrotic lesions. The lesions cover most of a leaf. Soon there won't be much left of the leaf. Sulfur dioxide causes injury when it is absorbed faster than it can be detoxified. The gas is oxidized to sulfate and sulfite, which is 30 times more toxic than sulfate. This interferes with photosynthesis and energy metabolism. This is a diagram showing how normal photosynthesis would work. During normal photosynthesis, the sun's energy is absorbed and metabolized to create oxygen through the plant's leaves. When sulfur dioxide is added, the leaves get damaged, so energy from the sun isn't absorbed as well. When the sun's energy isn't absorbed, it can't be metabolized to create oxygen or glucose. If there is a high concentration of sulfur dioxide, foliar necrosis can form even after a short period of time. Foliar necrosis is the death or decay of cells. You can notice these problems through the leaves of the plant. The most vulnerable types of leaves are the leaves that are in mid-growth, while younger and older leaves are less vulnerable to sulfur dioxide. You can tell the plant is contaminated if the leaves are bleached or pigmented. These injuries are known as chronic and acute injuries. An acute injury is caused by absorption of high concentrations of sulfur dioxide in short periods of time. This is a photo of leaves and pine needles with these acute injuries. Chronic injury is caused by long-term absorption of sulfur dioxide at sublethal concentrations. This picture is leaves that show chronic injuries. Chronic injuries also reduce growth and yield and increase senescence. Senescence is the final stage of plant development, during which the plant reclaims the valuable cellular building blocks that have been deposited in the leaves and other parts of the plant. Effects of sulfur dioxide are influenced by biological and environmental factors, like plant type, age, sunlight levels, and temperature. Plants vary in their tolerance for sulfur dioxide because of the difference in efficiency of which they absorb gases. If the dioxide levels are high, it still may not affect vegetation. You can tell if vegetation is affected by its physical appearance. If it changes, the plant's metabolism is impaired. These can get into dried fruits like raisins, apricots, and prunes. Sulfur dioxide can modify the responses of plants to abiotic and biotic stresses, such as intense sunlight and harmful fungi, by changing the plant's ability to detoxify pollutants and get rid of excess sulfurs. Sometimes, plants will even temporarily store pollutants so they don't react with other substances in the soil or plant that can potentially cause greater harm to it. A way to prevent sulfur oxides from being in the air is by using a scrubber. When sulfur is being burned and produces sulfur dioxide, the exhaust gases pass through the scrubber, where a spray mixture of limestone and water reacts with the sulfur dioxide. This helps the sulfur dioxide to be removed before it is released into the atmosphere, then into the plants. Sulfur oxides can be detrimental to plants by noticing changes in appearance of the plant's leaves. Damages to crop yields and other forms of vegetation can be determined. With increased use of scrubbers and decreasing the burning of fossil fuels, we can lower the amount of sulfur oxides in the air and lower the damages to plant life and growth.